Welcome to Homeschool Connections Physical Science class. Today we're going to finish up Chapter 2, The Properties of Matter, talking about chemical properties. We can describe matter using its chemical properties, its ability to change from one thing to something else. For example, when you're driving down the road in your car is mixing gasoline with oxygen to provide you with lots of energy, and out the tailpipe comes carbon dioxide and water. Okay, that gasoline and oxygen have combined and changed into something very different: carbon dioxide, water, and energy. When we describe the chemical properties of gasoline, we can say that it is reactive. It has the ability to react with other compounds and elements. It's flammable, which means you can start it on fire. And it releases a lot of energy. One of the products of burning gas is lots of energy. We cannot directly observe chemical properties. We can only observe them when they're taking place. We can look at gasoline in a can all day long and never be able to see its reactivity, its flammability, its release of energy until it takes part in a chemical reaction. Chemical properties can only be observed during a chemical change or a chemical reaction. A chemical change or chemical reactions occurs when one or more substances change into one or more new substances. They change the identity of the matter involved. In our previous example, gasoline and oxygen changed into carbon dioxide, water, and energy. Carbon dioxide, water, and energy are very different from gasoline and oxygen. When we talk about a chemical change or a chemical reaction, we're talking about what is actually taking place. When we talk about a chemical property, we are talking about the things that could happen to it, the types of reactions that could take place. Let's observe a chemical reaction. Here I have 3% hydrogen peroxide. You guys are likely to have this in your cabinet at home. And I'm going to about 3/4 fill this beaker with hydrogen peroxide. And then I'm going to add just a little bit of dish soap to it. Okay. And notice nothing is really happening. We don't observe anything. Now, that's no guarantee that no chemical reaction is happening, but I'll tell you, there's nothing happening here. We just now have a mixture of hydrogen peroxide and dish soap. But what happens when I add a scoop of yeast? Let's see. Let's give it a second and watch. Yeah, you guys see a lot of bubbles forming, don't you? The reaction of the yeast with the hydrogen peroxide is forming a gas, and our dish soap is making it so that we can see those gas bubbles, and it's going right over the edge. Though we can't always see a chemical reaction, often we do see some signs that a chemical change has taken place. For example, a color change will often indicate that we've had a chemical reaction. But be careful. If you observe your electric stove, you notice when it's cold, it's black, but when it's hot, it's red. Some things change color just as they heat up. Sometimes they give off an odor that wasn't there before, and there is after you've mixed them together. Sometimes there's fizzing or foaming like we just saw, or bubbling. Sometimes it's a temperature change. Have any of you guys used an instant hot or an instant cold, where you took the packet, it was room temperature, and you just cracked it, and it either got really hot or really cold? Those are chemical reactions taking place. Sometimes you can tell because there's an explosion, sound is giving off. Fireworks are a good example. That is a chemical reaction. Sometimes you have solids form. Look at the bottom left corner. We're mixing two clear liquids, and when they mix, some dark golden yellow solid is forming. If we see oxidation, that's a good sign that there's a chemical reaction. Oxidation is when you see something rust, like that car shown in the middle on the right, or tarnish. We've all seen silver tarnish and get kind of that dull hue on it. But remember, sometimes we have no visual clues that a chemical reaction has taken place. In your everyday life, you see chemical reactions happening all around you. You see iron rusting, eggs cooking, cake baking, electroplating a metal. That's if you have silver or gold coated jewelry. Every time you use a battery, there's a chemical reaction taking place. None of us much likes eating rotten fruit or rotten bananas, but that process of rotting is a chemical reaction. Grilling the burger. And if you have a fish tank and you have to keep it in a chemical balance so that the fish can live, that's chemical reactions. Okay, you digesting food, digesting your breakfast or your lunch, that is a chemical reaction taking place within your body. Grass growing, oh, doing our favorite job, laundry. Yep, that's a chemical reaction. If you enjoy sitting by a bonfire, the fire itself is a chemical reaction, and maybe you like making s'mores. That browning of the marshmallow is a chemical reaction. Chemical reactions take place all over, all around you, and chemical reactions take place inside you and all living things. All our bodily functions are chemical reactions. Characteristic properties are properties that can be either chemical or physical, and they help us identify a substance. Characteristic properties do not change, no matter if you have just a tiny amount or if you have a huge amount. For example, our gasoline. It doesn't matter if we have just a little bit of gasoline or if we have a whole barrel of it. It is always flammable. If we look at milk for an example, it has some physical properties that never change. It's always white, it's always a liquid. It doesn't matter if you have just a little bit left in your glass or if you have a whole gallon jug. Chemical properties, it doesn't matter if you have a tiny bit or a lot, it can always sour. And you can always digest it, you can drink it and use it to quench your thirst and provide you with energy. Those are some examples of characteristic properties of milk. Before we end this chapter, let's compare physical properties with chemical properties. First, physical properties can easily be observed without changing the identity of this substance. Remember when I was talking about physical properties, I had a big old piece of aluminum foil and I crumpled it up. The crumpling, changing the shape, was a physical property. But the aluminum is still aluminum. Nothing has changed with the identity of the substance. On the other hand, chemical properties can only be observed when the identity of the substance is changing, when the gasoline and oxygen is changing into carbon dioxide, water, and energy. Or in that demo, when the hydrogen peroxide was mixing with the yeast and giving off a gas. We could see those chemical properties as that chemical reaction was taking place. Had that chemical reaction not been taking place, we could have never observed those chemical properties. During a physical change, the composition doesn't change. The aluminum remained aluminum. During a chemical change, the composition changes. What you started with is very different from what you ended with. Many physical changes can easily be reversed. Remember, I had my ice and we saw it melting. I could easily get that back to ice. All I'd have to do is go stick it in the freezer for a little while. On the other hand, most chemical changes cannot be easily reversed. We cannot take carbon dioxide and water from the atmosphere and put a little energy in and easily create gasoline and oxygen. It just doesn't happen that way. We cannot easily uncook an egg. Okay, so chemical reactions, chemical changes are not easily reversed. And that is it for Chapter 2, Section 3. This is the end of the chapter. And in our next video, we will move on to Chapter 3. Until then, God bless.